Big hello to everybody. A couple of guys on the TEEP forum who have helped me out a fair bit, like many of the guys on the TEEP forum, were looking at a way to regulate the voltage on their charged battery. So because of their help, I decided to take a bit of time out, designed a very simple circuit that might help them out a bit. What I've done here is, for the primary charge battery, I'm just using a cap so we can see things happen quickly because we only get 15 minutes. I've gone from the positive of the run battery into the negative of the cap, which is our primary battery, and then bridge that negative to the second negative of the second charge battery. So what this is designed to do is, once this gets up close to the voltage that you've determined via the little pot there, it starts to fire the transistor up and send the charge voltage into a second charge battery. So what happens, the closer this gets to your predetermined voltage on your primary charge battery, the harder it fires the transistor and the more current it sends into the second charge battery. At the moment I've got this set up so I can range it between 12.5 and 13.5 volts on the primary charge battery. It's a very simple setup. We just come off the high voltage wire that normally goes to your charge battery, after the diode of course. That comes around, goes into a 1.2k resistor, and then continues on to the collector of the transistor. The pot I'm using is a 1k pot. Off the other side of the pot I've bridged 2 terminals out of the 3 to give us the full scale of the pot. There's a 1.5k resistor there. I've put a blocking diode in there. It's just a 1N4004. That stops any bleed back from the positive to the negative once you switch the system off. So after that diode, that just goes around to the negative side of your run battery. If you want a wider range, drop this resistor down to a 1k resistor and put a 2k pot in. That gives you between 11.2 and 14.4 volts that you can set your charge battery at. Like I said, at the moment I've got it set at about 12.5, and once that gets up to the 12.5 it won't charge anymore. All the power will be going through the second transistor and into the second battery. So what I've got here is, this is our primary battery, in this case the cap, just like I said, so we can see it happen fairly quick. This is the amps going into the second charge battery, and that's the voltage on our second charge battery. So what you'll see is, when this gets close, I think at about 10.5, 11 volts, it starts to fire the transistor and start sending some of the current into the second charge battery. The closer this gets to 12.5, the higher this will climb. So I'll start her up. As you can see, we hit about 11.5 volts, and then it started sending some of the charge into the second charge battery. This takes a little while to wind up because I've put the big flywheel on just to try and slow it down so you could see the effect. So like I said, the closer this gets to our 12.5, the more that'll start sending into the second charge battery. As you can see, the voltage is starting to climb in that, because our primary charge battery is getting close to the 12.5. And as you'll see, the amps into the second battery slowly go up as we get closer to the 12.5 on the primary battery. Now simply just by turning this pot here, which I'll show you, I can go set it to 12.5 or up to the 13.4, 13.5 volts. So you just select what you want to charge your battery at and set it at that. A decent 12 volt battery will take 13.5 volts charge, between 13.3 and 13.5. So as you can see, the second charge battery is starting to go up fairly quick now that the primary charge battery is getting close to the set 12.5 volts. So yeah, very simple little circuit. Took a bit of mucking around, a bit of testing. Depending on what transistor you use is going to depend or determine the resistance you need here to fire that up when you want it to fire up. So like I said, this starts to fire up at about 11.5 volts. So the other good thing that happens is the closer the primary battery gets to the selected 12.5 volts, the slower the charge rate starts to go in until it's down to a trickle charge. Now, a trickle charge is a very good way of topping up a 12 volt battery to give it its full capacity. The high voltage spikes are still there. All it's doing is taking amperage out of those voltage spikes and putting it into the second battery. So the effect is still the same as you get with the Bedini SSG. Okay, the transistor I'm using, I have been using 2N3055s, which is that one in there. I found these ones down at our electronics store yesterday. They're a BUX 80, slightly lower power, but still a 10 amp continuous, 15 amp peak transistor, and there's no way most of us will be putting more than 10 amps through it continuous because they're pulses anyway. So beautiful little transistor. I'm going to swap the 2N3055 with it tomorrow and see if I get a better performance. Like I said, slightly lower power. We'll handle 600 volts at 10 amps, so 600 volt pulses at 10 amps, or I'd say 160 volt continuous at 10 amps, 15 amp peak. So nice little transistor. You can see we're very close to our 12.5 volts now that I've selected. So a good 98% of the charge is now going into the second charge battery. So if you're ever worried about leaving your motor running, charging up one battery overnight and overcharging it, problem solved. Charge the second battery once that one's full. I'll draw up a schematic for it, post it on the TEEP forum as soon as I get 10 minutes. But yeah, very effective. If we want to go to the 13.5 volts, we can just wind her up to that. And set our voltage at that. That'll charge the battery to 13.5 and then send it all into the secondary battery. So I hope that's helped a few of you out with your overcharging problems, and till next time.